Okay, guys, we're into the section now where I'm looking for a function rule for a given table. Um, and so, oh, look at that. It should say f of x. That's fine. It says y and f of x are the same thing. Um, so I'm looking for the function rule. And first thing I want to see, um, remember, I want to know, is this going to be an exponential growth? Maybe it's going to be an exponential decay. And then I'm not going to write it in there because I don't have room, but it could be a linear growth or a linear decay or an increasing linear or a decreasing linear. So first thing, when I'm going to look at 13 now, when I look at 13, I look at what's the pattern look like. Does it look like I'm adding the same thing every time or subtracting the same thing every time? Or am I multiplying or dividing by the same thing every time? And as I look at it, so the difference between 24 and 12, well, that difference is 12 and this difference is only 6. So I'm not adding or subtracting by the same thing every time, so it must be exponential. Now specifically, I know it's getting smaller, so it must be exponential decay. All right, so this is what it is. It's exponential decay. So same thing. All I'm going to do is I'm going to write down for my function, my starting point is first. Okay. Now I get this 24 as my starting point because I look down at the table and I see that the y-intercept, or the value of y when x equals 0, is 24. So that's always my starting point. Now what am I going to multiply by as my decay rate? So remember, a really easy way to do this is take any number in your table and divide it by the previous number. So I'm going to take 3 and divide it by the previous number, which is 6. So 3 divided by 6, when I reduce that, reduces down to 1/2. So 1/2 is going to be my decay rate, which makes sense because 1/2 is smaller than 1, and we know that decay rates must be smaller than 1. Now I'm going to raise that to the x power, and there we go. I've written an exponential decay function to represent the table for number 13.